Thank you for tuning in. So, how many of you have heard of the late Colonel John Boyd? Not many, I suspect, so I'm going to begin with a story. It is the late 1970s, and the retired Colonel Boyd maintains an office in the Pentagon as a consultant. Colonel James Burton comes into Boyd's office. Burton is the epitome of careerist. Burton's career was fast-tracked ever since being part of the first graduating class of the newly created Air Force Academy. Burton has been assigned to supervise the testing of the Army's new Bradley fighting vehicle. The Army was not performing realistic tests, which was putting soldiers' lives in danger. This was going to be a test case for UDA, as the insurgent Burton goes up against the entire mass of the Army. The Army, like in Vietnam, was going to use its attrition warfare strategy against the lonely Colonel Burton, who only had his wits and Boyd's UDA-based maneuver warfare strategy. After years of warfare, Burton defeated the Army, much like the North Vietnamese defeated the Army 10 years earlier. The Bradley was redesigned, and this redesigned Bradley saved lives in the first Gulf War. Burton proved that the computer models that were used in place of live fire testing were worthless. The Army changed its policy for future weapons testings to use real enemy weapons instead of computer models. This presentation is part 4, covering Boyd the Reformer and Strategist. Boyd's F-15 and F-16 experience in the Pentagon showed him that there was need for reform in the weapons procurement process. Boyd's reform efforts may yield some insight into a company's decision whether or not to upgrade or replace their DCS. Boyd's last major project was to reform Army combat doctrine from attrition warfare to what he would term maneuver warfare. The Army was slow to change, but the smaller and nimbler Marine Corps embraced Boyd's ideas. The concepts of maneuver warfare will be applied to process automation issues such as DCS replacement and how to deal with obsolete I/O. In this global economy, does a manufacturing company need to replace its DCS systems to compete? First thing would be to evaluate the current DCS in terms of its ability to support UDA. Are all valves and motors automated? Or in other words, are operators throwing hand valves or pushing field stop-start buttons as part of the routine operation of the equipment? Do all of the unit operations have startup, shutdown, and turnaround sequences? Are all of the operator positions organized under the air traffic controller model using the query display? If the answers of those questions are no, can adding these give the same benefit as a DCS replacement? If the answers of those questions are yes, then the new DCS must retain these UDA-friendly features. A replacement DCS project may be justified by the added new features, but success or failure will be its impact on UDA. A hopeless legacy DCS that is replaced without UDA features represents a large capital investment for only incremental gain. A flawed legacy DCS that resolves the basics but still has gaps in UDA features represents a smaller capital investment for incremental gain. The goal is an UDA-based DCS. The Air Force had 2 fighters as Boyd entered the Pentagon in the 1960s. The F-111 was the most technologically advanced fighter in the Air Force. Boyd's EM theory showed that the F-111 was inferior to all Soviet fighters under every possible situation. The Air Force started the FX program to replace the F-111. This was going to be a huge cost with little improvement. The F-4 was poor, but not hopeless like the F-111. The addition of a cannon made a huge improvement at very low cost. What was needed was a complete change in fighter requirements. Starting with a blank piece of paper and using EM theory, Boyd came up with the F-15. Although the concept of OODA would not come into being until years later, the F-15 had OODA features such as the bubble canopy and quick change in directions. Rather than hydraulic-assisted controls like the F-86, it was Boyd's EM theory that made the F-15 the most maneuverable fighter in the world. The FX program to replace the F-111 could not yield a world-class fighter like the F-15. There were not enough incremental changes that could be done to the F-4 to make it a world-class fighter. The question for a company today is whether or not their existing DCS is more like the hopeless F-111 or the F-4. After reviewing the series so far, can the existing DCS be modified to add all of the listed OODA capabilities? If your company does plan to replace the DCS, will the new DCS have all of the listed OODA capabilities? So, does the existing DCS need to be replaced? The answer is yes, if it is the only way to achieve the OODA features needed for a 21st century manufacturing plant. A replacement DCS project can have many pitfalls. The A-12 project was one of the Pentagon's largest procurement failures. The Navy wanted to replace the A-6 Intruder with a new A-12. Like many existing DCS systems, the prospect of incremental improvement to gain longer service life was ruled out. Early cost overrun predictions on the A-12 were ignored. Scrutinize any proposal for a DCS upgrade. Are there any errors? Are the savings claims realistic? There were no independent auditors on the A-12 project. If there are savings promised with a new DCS, can they be audited? Are the savings called out to specific plant budget line items? Are these savings impossible to achieve with the existing DCS? With the A-12, there was the promise of sexy stealth technology that attracted the generals. Some of the new DCS systems will also offer sexy new technologies like APC and simulation. Is DCS replacement the only way to adopt these technologies? Beware of a lack of prototype. The A-12 project was approved on a paper proposal. Is the new DCS proposal just paper? The F-16 was successful in part because two prototypes were built from competing vendors. They were evaluated against each other with a head-to-head flying competition and evaluated against the project design claims. Can the potential savings from a replacement DCS be demonstrated on a piece of equipment compared with similar equipment running under the old DCS? The A-12, like other Pentagon weapons programs, was extremely difficult to cancel once approved. Once a DCS replacement starts, it is very difficult to go back, if not impossible. The result of the A-12 project was $1 billion spent without a single plane built. It was not just the Navy with procurement problems. The Army and the Air Force had plenty of examples. The Pentagon reformers wanted data-driven decisions. For planes, this was a comparison of performance, kill ratio, versus sortie cost. The F-86 had a kill ratio of 10-1. The F-4, 1-1. The F-15, 35-0. The sortie cost for the F-86 was 2.1 missions per $1 million. The F-4, 0.12 missions per $1 million. The F-15, 0.05. The F-15 was a huge success. The F-15 cost twice as much to maintain, but was 35 times more effective. The F-4 was obviously a failure under these metrics. For a new DCS, productivity could be the production volume per number of operators. The maintenance cost could be as simple as the software licensing agreement. So, Can the new proposed DCS get more volume out per operator at lower annual licensing fees? Or we can use a metric that is not dependent on external market conditions. In part 3 of this series, I presented a metric, number of operators per I/O count. Can the operators manage more I/O with the new proposed DCS? The initial DCS installs to eliminate control panels in the 1990s allowed for a reduction in operator headcount for the same I/O count. It is reasonable to expect any replacement DCS to do the same. Headcount and annual software maintenance agreement costs are easy to measure and easy to audit. Any generic promises of efficiency improvements should ultimately end up in reduced headcount. This brings up Boyd the strategist and the concept of maneuver warfare. One of the current issues in process automation is obsolete I/O, and this may be how Boyd would handle it. According to Boyd, the German invasion of France in 1940 is a textbook example of OODA in action for armies. The mission order was to reach the English Channel. This simple order allowed everyone from the field commander down to the private foot soldier to understand and figure out the best way to accomplish. Obsolete I/O has a similar mission order: upgrade to Ethernet-based I/O. The Germans wanted more blitz, speed, which would equal less Krieg, war. The Ardennes had the least defense, so this was the focus of the German attack. To keep speed, the field commander, Heinz Guderian, the inventor of Blitzkrieg, stopped using wireless communication in order to hide his panzer's movements from headquarters. This avoided delays from high command caused by micromanagement. The same could be applied to obsolete I/O. Move fast. Overwhelm the plant with superior numbers to remove the obsolete I/O fast. If the plant has a planned maintenance shutdown, flood the plant with automation folks to knock out as much as possible when downtime is free. By free, I mean the downtime is charged to another entity besides process automation. Bypass the toughest systems. Like an enemy town, once surrounded, it will be easier to tackle. The last obsolete I/O will have the undivided attention of all automation staff to resolve. Avoid broad front campaigns. The Germans avoided the Maginot Line and attacked on a narrow gap between the French and British armies. The French in the Ardennes were defeated fast. The rest surrendered and never had to be attacked. For obsolete I/O, doing all the plants at once means never finishing any plant earlier than another. Once each plant is complete, 100%, all others will be easier as the number of plants with obsolete I/O goes down while the automation headcount remains constant. Blitz, the replacement of obsolete I/O to avoid prolonged risk of I/O failure. Here is a map of the German advance into France in 1940. The tanks were massed and had numerical superiority at the point of attack. The stick figure represents the operators and engineers. The tanks represent automation folks. Typical plants have a ratio of operators per automation folks, just like the French, which assigned each infantry division a small number of tanks. The Panzer Division innovation masked the tanks. In terms of obsolete I/O, each plant should be attacked with a large number of automation personnel in order to replace the I/O much faster. With each complete plant, the obsolescence risk to the company gets smaller. Automation folks need to be the spearhead, knocking out plant after plant. Automation folks should have mission orders such that they can prioritize and execute I/O replacement independent of senior management. This avoids delays and gets the job done faster, which ultimately will result in less cost and a faster dissipation of obsolescence risk. This same model can be used for alarm management. The operations folks have to rationalize the alarms. Once done, by sending a large number of automation folks to execute the rationalization plan, the quicker the OODA benefits can happen. This same model can be used for state-based sequence use. The operations folks have to write control narratives as to how the equipment should start up, shut down, and turn around. Once done, by sending a large number of automation folks to execute the control narratives, the quicker the OODA benefits can happen. So what are some examples of not following maneuver warfare strategy? There is the case of the Allies in France in 1944. The mission order for the Allies was to advance across a broad front such that every unit gets to the Rhine River at once. This strategy led to more Krieg, war, and less Blitz, speed. Allied headquarters stopped Patton by diverting resources to the British in Belgium and Holland. This was the hardest part of the advance because of all of the rivers. In terms of automation, upgrading all plants at once would be a mission order that goes against Boyd's maneuver warfare theory. 10 plants may take 10 years to upgrade. The slow-moving plants attract more resources from other plants, further slowing progress. The fast-moving plants would be slowed as automation folks sit idle, waiting for approval of the next I/O system rather than being free to take advantage of opportunities. I believe Boyd would centralize automation staff such that they are not assigned to any particular plant. To take advantage of downtime opportunities, Boyd would mass automation like General Guderian massed his panzers. This was more effective than the French strategy of spreading out their tanks into all of the infantry divisions, aka spreading automation folks across many plants. Maneuver warfare would delegate authority by providing a pool of money controlled by a generic scope. This would bring the full power of innovation and individual initiative to achieve the impossible, much like the German army defeated the numerically superior British and French armies in 1940. Here's the map of France in 1944. The circle is the broad front. Patton had moved farther east than Montgomery. Operation Market Garden was created to stop Patton and get the British Army farther east to catch up. If the Americans followed the German strategy of 1940, then Patton would have turned north and surrounded the Germans in Belgium and Holland, and most likely would have ended the war in 1944. This didn't happen, and the delay to get the British caught up allowed for the German counterattack, the Battle of the Bulge, the most costly battle in World War II for the Americans. It is hard to predict which obsolete I/O system will fail first. The only guarantee of avoiding this is 100% replacement. A broad front strategy could result in a Battle of the Bulge counterattack in the form of an obsolete I/O failure, causing a production interruption from a plant that could have already been completely upgraded if a maneuver warfare strategy had been used. To show that the Army was very capable of resisting change, the Gulf War battle plan was similar to France in 1944. The broad front strategy hindered the advance of Boyd's left hook. None of the 3 divisions of the left hook could move any faster than the slowest one. The Army called this synchronicity. The slow advance of the left hook allowed Saddam's Republican Guard divisions to escape. This kept Saddam in power and forced a second Gulf War, which turned into another Vietnam for America. In terms of obsolete I/O, Kuwait could be a plant with a lot of obsolete I/O. The attrition warfare strategy would be to slowly replace one I/O system after another over many years. The left hook option could be replacing most, if not all, of the obsolete I/O if the plant goes down for maintenance or some other unexpected reason. To implement the left hook, automation folks need to have quick access to money and contractors to get the job done quickly. The speed blitz avoids the war Krieg by avoiding additional production downtime. General Tommy Franks micromanaged the left hook. The first division to reach their objective would have to stop and wait until the other two divisions reached theirs. Only then could all three divisions receive new objectives. The Iraqi army couldn't stop the divisions of the left hook, only Army headquarters. Synchronicity for obsolete I/O systems means that no single automation team can move faster than another. Once an I/O system is upgraded, the automation team has to wait for senior management to approve the next system before continuing to work. Without synchronicity, the productivity of the automation staff stays at 100%, as there is no waiting for, say, 3 months, a year for senior management to approve each new I/O system to upgrade. This scenario can be applied to DCS replacement. Kuwait can be any plant. The attrition path is the simple replace everything in a big shutdown with lots of contractors. One aspect of maneuver warfare was to attack weakness with overwhelming force. Another aspect is deception. Maneuver warfare is based in the OODA loop. We want to get into the mind of the existing DCS vendor and defeat them mentally. The left hook or marine feint could be threats to the existing DCS vendor that they will lose business without making improvements to improve OODA performance. The left hook could be to replace some old parts of the plant based on the ability to fully utilize the advanced DCS features. Hence, half the project does not need to be attacked, much like the bypassed French armies defending the Maginot Line in 1940. The left hook could be to form alliances with other existing legacy DCS customers to pressure the legacy DCS executives to make improvements like adding OODA features. The goal is an OODA-based DCS. Getting the legacy DCS vendor to make improvements is cheaper than DCS replacement. Getting all customers to act together is like cutting off the retreat of the Iraqi Republican Guard. There would be limited customers to rely on to sustain the legacy DCS business. For maneuver warfare, there will be automation staffing changes. The old way allocates automation folks to support plants based on the number of operators and engineers. Plants support their own IE techs, projects, and process engineers. A large number of projects is hurt by limited automation staffing, while a low number of projects idles automation staffing. The new way would be to continue to support IE techs with automation folks as before. However, projects and process engineering would utilize additional operators and engineers to write control narratives, which would then be moved to automation groups dedicated to projects and process engineering support. This keeps automation folks busy as they cover multiple plants. This forces plant personnel to think through what type of automation they want before making a request. Plant-based automation resources facilitates half-thought-out code requests, forcing an iteration or trial-and-error creation process for automation. Automation folks need to be able to exploit opportunities across the company. The Germans defeated a numerically superior French army. Automation resources, organized along similar lines, could defeat a superior volume of challenges. I wanted to touch on one last topic, and that is competitive bidding. Boyd asked around the Pentagon to see if there were any weapons projects that actually cost less than the initial proposal. There was only one: the cannon shells for the A-10 Warthog. The shells were competitively bid between two companies. The winner got 70% of the business, and the loser got 30% of the business. Having single vendors means no matter how hard or how costly, there is only one option. A large amount of management is required to hold accountable those vendors with a monopoly. Multiple vendors allow competition which forces innovation and ultimately lower cost. Market forces hold the vendors accountable with very little management effort. Standards should be specified by dimensions or capabilities, not by brand names. This allows for the interchangeability of vendors. This concludes Part 4 of the Boyd on Automation series. In Part 5, the final installment, we will summarize and make recommendations. I'm John Hauge. I hope you enjoyed this mixture of process automation and military history, two passions of mine. I thank you for your interest and your time, and I hope you tune in for the next in this series.